Hello folks, this is Steve Oberg, and just wanted to go over a couple things with regard to standard deviation. Chapter 3 gives you kind of a weird formula that we're going to look at here. We're going to look at it in detail, and if you've done the reading, then you should have a pretty good heads up. But I wanted to walk through this algorithm with you, which is basically just a method or a series of steps to come to the right answer with regard to a formula like this. First off, your book has you finding the standard deviation, which is just denoted for samples as just the letter S, the capital letter S, and then squaring it to get the S squared. But basically, if you do the formula correctly, you're going to get your variance, which is S squared, first, and then it's easy just to take the standard deviation, because what we're supposed to do is sum the squares and then divide by the number in your sample minus 1 to get the S squared, or the variance, and then you can just easily take the square root and then find your standard deviation. So I've got a small data set here, so we can walk through how to do this. And basically, all we're going to do is just find the mean of this we're going to call it a sample, because we're dealing with sample parameters, which is just your x bar. So 5 plus 6 plus 3 plus 5 plus 4 plus 7. I'll save you the trouble. We've got a calculator open over here. But it equals 30, and we have 6 terms. So 1, 2, 3, 4, 5, 6. So sum all of those together, divide by 6. We have 30 divided by 6, and so the mean of this sample is 5. So I've got that highlighted in red for you, just so we can look at it. So we have 5, so we'll just insert our means just to make doing the math easy. And what we're going to do, according to this formula over here, this Greek letter S, it's a sigma, and what that means is you just add up everything here to the right. You're going to add up these terms. If you're familiar with Excel, and you guys should have had an Excel class or a computer class, you'll know that this key up here, the sum function, that's what it does, is it adds up everything that you want to highlight. So if we sum, what we're going to sum is x to the I, which is I've got it listed over here. It's basically whatever terms you want, and it's to the I. So I number of x terms. We could call this z terms or q terms, whatever you want to call them. For the most part, we're going to be using x and y. So x to the I minus x with this little line over it is the mean of a sample. Mean just being the mathematical average of this set of terms. So each one of these terms minus the mean, and then we're going to square that term. So let's do that. So what's 5 minus 5 is just 0. 6 minus 5 is 1. 3 minus 5 is negative 2. 5 minus 5 again is 0. 4 minus 5 is negative 1. And 7 minus 5 is 2. Now you'll notice something. If we were to sum these terms, you're going to come up with 0. 0 plus 1 is 1. Minus 2 is, or plus negative 2 would be then negative 1. Plus 0 is still negative 1. Plus a negative 1, it would be a negative 2. Plus 2 then equals 0. So if we did this correctly, this should add up to 0, because what you're dealing with is basically each one of these terms and its difference from the mean. And so each one of these is going to average each other out, and so when you add them together, because they're all a certain distance from the mean, if you have the mean in the middle, then you add all these together, one of these is greater than the mean, the others are smaller, then these should equal 0. So if you did it right, you can go back and check your math if you're dealing with a large set. If it doesn't equal 0, then you mess up your math somewhere. In the classroom at McMurray College, this is one of the areas where people trip up, and we're able to just find the error really quickly here. So the next thing that this algorithm tells us to do is to square these terms. So what we're going to do is x to the I minus x bar, or x minus the mean, squared. So 0 squared is still 0. 1 squared is still 1. Negative 2 squared is going to be a positive 4. And one of the reasons we square these terms actually is to get rid of the negative signs. And you can just basically look at it in terms of absolute value, which is just how far is it from the mean. We're not caring about positives and negatives, really, but what we're doing is we're getting rid of that negative sign. So 0 squared is still 0. Negative 1 squared is positive 1, then 2 squared is 4. So if we're to add all these together, then 0 plus 1 is 0, plus 4 is 5, plus 0 is still 5, and then we got 5 more. We've got 10. So our sum of squares is 10. Next thing our formula tells us to do is then to divide by n minus 1. N is just a sexy way of saying the number of terms in our data set. So in this case we have 1, 2, 3, 4, 5, 6 terms. So 6 minus 1 is 5. So 10 divided by 5 is 2. And so then we're going to then find the square root of 2. So let's clear this. And 2, let's take the square root. And it's going to be we're going to call it 1.41. So our standard deviation, well, let's do that correctly, 1.41, and we'll clear that. So our standard deviation in this case of this data set is 1.41, which just basically means that any one of these terms is, on average, basically 1.41, whatever it is you're dealing with. It could be 5 bowling pins, 5 home runs, 5 miles to work, 3 miles to work, whatever these are, whatever these terms are, our standard deviation is basically plus or minus 1.41. Any one of these given terms is 1.41 of whatever it is from the mean. I hope that's helpful for now. And if you have any questions, please look me up. One last quick word. I don't expect you to do your homework with in Excel with these fancy terms. I took a little while and built the formulas for you just so that it would look the same as the book. I'm fine if we just I want to see what you're doing initially, especially with finding your standard deviation. So set it up something like this, but you can just use regular old letters X, and then you can call it X bar, or you can just call it the mean, X minus mean squared, just SQR, whatever. All I want to do is just make sure that we're doing this algorithm correctly, because it can be a little bit daunting until you see it done simply like this. So hopefully this was helpful. Reach out to me if you got any questions, and we'll see you on the other side. Bye-bye.